All right, I'm going to get started, and anyone who signed up for this webinar can just join in live and follow as we go along. All right, so welcome to this online event. I will I'll do a quick presentation on the importance of machine learning. So if you're a software developer, why machine learning is super important and crucial for your career right now. If you want to develop an interesting niche, if you want to distinguish yourself from your colleagues, if you want to improve your career position as a developer. AI, machine learning, deep learning, computer vision, these are all super crucial skills. They're fairly easy to learn, and they are starting to open up for developers. So this is a really interesting opportunity. It's a very strategic career move that you can do right now. So I'll give you some background on what's going on in machine learning and why now is an excellent moment to get started and to develop your AI and machine learning skills and take your career to the next level, so to speak. So I got a presentation on that. Afterwards, I will do a code demo. So I've got a little demo. It's an application, C# application, that uses CNTK. That's the Microsoft Neural Network Library. CNTK stands for the Cognitive Toolkit, and it's basically Microsoft's answer to TensorFlow. So it's literally a tensor library, like the libraries that we use to run neural networks, but it's not TensorFlow, it's not Python, it's 100% Microsoft code. And the nice thing about CNTK is it's really fast. It runs roughly twice as fast as TensorFlow. So that's pretty awesome. It also means that because it's a Microsoft library, we can tap directly into the library from C# code. If you try to call TensorFlow from C# code, it's really difficult because TensorFlow is specifically designed for Python and not for a strict type language like C#. So it's a bit of a kludge to interface C# with TensorFlow. CNTK works a lot better. So I'm going to show you that. I have a little app that I'm working with a data set of houses in Boston. So this is the famous Boston housing data set. And I'm training a neural network to predict the value of any given house in Boston. So I'm training my neural network on a data file, and then the idea is that I can just plug in any kind of figures, any kind of information on a house, and the neural network will make an accurate prediction of what that house is worth. So it's a little application written for CNTK in C#. So I'll demo that at the end of this presentation. Okay, so let's get started. So I have this cool Service Book 2 pen. And when you're in PowerPoint, you can actually use the button at the top of the pen to advance the slide. So let's see if that works. Amazing. I love the 21st century. Okay, so the first thing I want to touch on is the concept of a red ocean and a blue ocean. These are marketing terms. They apply to how hard it is to sell a product in a certain market, but we can also use these terms for the job market. A red ocean job market is a job market with ultra high levels of competition. We call it a red ocean because it's, you have to imagine it's an ocean filled with sharks. So the ocean is full of fish, you know, so lots of fish. So if you're a predator, if you're a shark, there's tasty fish everywhere. So you can eat anything you like. But unfortunately, the ocean is just packed with sharks. There's sharks everywhere. In front of you, behind you, below you, everywhere are sharks. So if you're a shark and you're trying to eat a fish, you're going to have a lot of competition. It's going to be really hard to get your food every day. So that's why they call it a red ocean. And being in a red ocean has a bunch of disadvantages. High levels of competition, you have no job security, wages are low because there's so much competition. So there's a huge downward pressure on wages. You could get fired any second. You have no freedom in your career, in your work. You basically have to do what your boss tells you to. You can't pick and choose your own projects. So it's not a very nice position to be in. You end up in a red ocean when your specializations So the software development specializations that you have are no longer unique. Too many other people have them too. Good example is mobile app development. Mobile app development used to be a niche skill, and you could really boost your career by being a mobile app developer. You would have a high salary, good job security, you can pick and choose your own projects, but then everyone else also became a mobile app developer. And now the field is just packed. Web front-end development, so UX design, is also becoming a red ocean. Any kind of generic software development, client-server development, it's all red oceans. So you have to be very careful when selecting niches, when selecting specializations. Anything you pick will eventually become a red ocean. You'll never have job security forever in IT. You can pick interesting fields to study, and you can try to be the first person to have a certain skill. But if you wait 10, 15 years, then everyone else will have that skill too. So anything will eventually turn into a red ocean. But you want to be at the start of that trend. So we call that a blue ocean. A blue ocean is a big ocean packed with fish, and you're the only shark. There are no other sharks in the ocean. So this means in the job market, you have a skill that no one else has, or there are only 10 people in the entire state that have your specific skill. So if companies want to do anything with that specific skill, they want an application around that expertise, they have to come to you because there's no one else. So that's called a blue ocean. I can give you an example. In the past, I think about 15 years ago, I was a BizTalk trainer in the Netherlands, BizTalk 2004. And there was one other BizTalk trainer in the Netherlands. So just me and one other guy. So that was absolutely fantastic because every month, 1 or 2 companies wanted the BizTalk training. So they could either call me or the other guy. That was it. So I had, on average, I had 1 training per month, and I didn't have to do any acquisition, any sales, any marketing. People would just call me and ask me to do a training, and I could just refuse trainings. I could say, oh, I'll do that one, but I won't do that one. So I could pick and choose my own projects. So that's a blue ocean, and it's absolutely awesome. You want to be in a blue ocean. It means you have job security, you'll have high wages, you can pick and choose your own projects, and everything is just fantastic. So how do you get into a blue ocean? Pick a niche that is in demand, but where there aren't many other software developers on the market with that particular skill. And a really good example is AI. AI, machine learning, deep learning, computer vision. These are very complicated subjects that are slowly becoming easier and easier because the libraries, the software libraries, are getting better and better. Right now, we have fantastic AI software libraries. They're really awesome. And it is super easy for a software developer to branch out into AI and add that to your skill set. You could literally become an AI developer over the course of a couple of months. I'd say between 4 or 6 months of intensive study, and you would have a deep understanding of AI. You would understand data science algorithms, neural networks, deep neural networks, convolution, computer vision, recurrent neural networks, text analysis with attention networks, transformer neural networks, which are high tech right now. All that stuff you can learn, and it's fairly easy. It's getting quite easy to pick up. If you do that, you're in a blue ocean because every single company right now wants AI, and there aren't many software developers on the market with that particular skill set. So you would literally move into a blue ocean. Now, eventually this will become a red ocean. Eventually everyone will know AI. All the software developers will be fluent in AI. We'll reach that point in maybe 10 years, 15 years if we're lucky. But that means you will have job security for the next 10 years. That's pretty awesome. So if you look at the AI market, the growth of the AI market is just crazy. It's growing rapidly year after year. So I've highlighted 2019. Now the orange line, below that line, it says deep learning. So this is the skill, the particular skill of building neural networks, deep neural networks, training them on data, and then using them to make valuable business predictions. So that whole subset of AI is called deep learning. And look at that growth. It's just crazy. So If you are skilled in deep learning, if you can build neural networks in C# with C# libraries, you have a huge advantage. You're surfing that wave, that growth cycle, and you're going to be fine for the next 10 years. And pretty much every field in AI is growing. Natural language processing is growing like crazy. Computer vision is growing like crazy. Deep learning is growing. Everything is in flux and evolving rapidly. So it's a really cool field to be in right now. So you might be thinking, it's too complex for me, you know, AI, machine learning, that's like really complicated, mathematics, you need to be like a PhD in math to be able to even get it, you know, it's only for super geniuses. You need an IQ of at least 190 to be productive in AI. Not true. This might have been so in the past. In the past, all these AI algorithms were not developed yet. They weren't completed yet. Our understanding of neural networks was very limited. So it's true, you needed a PhD in math to be able to be productive in AI. But now we have a good understanding of neural networks. We have several libraries that can design, build, and run neural networks at scale. And the math is basically contained in a black box. So instead of a deep understanding of neural networks, you can actually treat a neural network as a black box. You can understand the pros and cons of a neural network, how to design one, the different kinds of architectures, neural network architectures, and what kind of impact they have on the behavior of the neural net, all without touching a single mathematical expression. So we've reached a point where you don't need the math understanding to be productive. It helps if you have a basic understanding of math, if you kind of understand the mathematics behind neural networks, but you don't need that knowledge right now. You can actually get started as a software developer, throwing neural nets into your code left and right, and using them to create cool new business applications. And it's super easy. And so you don't need to be an expert. So what I mean with this slide is when you're building apps, you understand your application, but I don't think you're able to build your own C# compiler, right? I mean, not many of us are able to build compilers. It's a fairly specialized niche topic. And we can go further down the tech pyramid. Below the C# compiler, we have the JIT compiler and the .NET runtime environment. I mean, could you build that? Do you understand how the thing works? How JIT compilation actually works? Below that is the hardware level. So we're talking about 64-bit machine language and the CPU and GPU hardware. You're probably not able to build your own CPU, right? Or understand the inner workings of a GPU. You don't need that knowledge to be productive in C#. You can build C# applications with a dim understanding of the compiler. That's it. The only thing you need to know is how the C# language works, how to build good applications, the conventions of good application design, and a bit of understanding about performance. And that's enough to be productive. So if I map that to the field of machine learning, in machine learning, you need to understand the different kind of algorithms that we have and the application that you're trying to build, and that's it. If you know the pros and cons of all the algorithms, if you know the pros and cons of every specific neural network architecture, then that is enough to get started. And there are many layers below that. You've got the tensor library below that. You've got matrix algebra, which is the foundation for pretty much all neural networks that we have right now. There is this cool GPU driver API called CUDA, which allows you to run that matrix algebra on a GPU. I have no idea how CUDA works. I mean, I know it exists, and I know that I need to install a CUDA driver to be able to run my neural networks, but I've never ever looked at the CUDA API. So yeah, I don't have that knowledge, and I can be productive with neural networks without that specific knowledge. So we're now at a point where just a understanding of that top level of the tech pyramid is enough to be productive. So it's a really cool place in time to be. Machine learning, AI, has become commoditized. It's like Lego, basically. We're assembling applications by just stacking Lego bricks together, and our understanding of what's inside a brick is no longer necessary to be able to build something cool with Lego. So it's a very interesting time, and it means that any software developer, if you're a software developer, you can transition into AI and machine learning today. You can actually do this. And if you do that, that gets you into the blue ocean. So the cool library that Microsoft designed, which I touched on earlier, is called the Microsoft Cognitive Toolkit, or CNTK. And it's a tensor library. So this means it's a library that does the type of matrix algebra that you need to run neural networks. So in CNTK, you can design neural networks, very complex ones, and you can run them, and you can use these neural networks to make predictions. You can train a neural network on data, and then you can use this trained network to make specific predictions. So CNTK is pretty cool. It's open sourced. So it was invented in 2012 and open sourced in 2016. It has 16,500 stars on GitHub, so it's very popular. And there's like more than 140 contributors from all over the world adding code to this library. So this is a really cool library. And this is Microsoft's answer to TensorFlow. So this library pretty much does the same thing as what TensorFlow does. It hosts and runs neural networks. I'll show you how to train and run a neural network in the code demo at the end of the presentation. So CNTK is pretty cool. It's a NuGet package, so you can just add it to any application through NuGet, and it will run on .NET Core or the conventional .NET framework. So if you're designing for .NET Core, that'll work. If you use the 4.6 framework, that will also work. The thing is totally happy. It's a single package. So you pull in one package and you have full AI neural network support in your application. So it's super easy to get started. So I've created a series of courses to help you get started in machine learning, because this is such an exciting time for C# and machine learning development. So I've got a whole bunch of courses because this is a very wide field. And I've created separate courses that zoom in on specific aspects of C# development. So this is really cool because if you look on the internet, if you Google, 99.9% of all AI courses are Python. Everything is Python. And that's all good, that's all fine, you know, but I'm a C# developer. I really love C#. I love the strong typed nature of C#. I love the syntax. It's a beautiful language, beautiful compiler, beautiful runtime environment. And if I have to go to Python to host and run my neural networks, well, that makes me sad. You know, I don't want to make that step. The bridge between C# and Python, it's a bit of a kludge. It's possible to bridge those two domains, but it's not super easy. So I'm always on the lookout for how to natively run AI code in C#, you know, without having to go through a Python interpreter. And there are two great libraries right now that you can use for that. One is ML.NET. ML.NET. It's the new Microsoft machine learning language, which it supports pretty much all the major data science algorithms. So any kind of data science algorithm you want to use, it's in ML.NET and you can just plonk it in your code. However, if you want to design complex neural networks, there's a different library for that called CNTK. So CNTK, the Cognitive Toolkit, will allow you to design and build very complex, multi-layered deep neural networks and use those in your code. So I've created two courses around that. I'm also working on a course on computer vision. So that's stuff like head tracking, full body tracking, you know, like the Kinect functionality where there's a camera filming and then the computer can track your motion, can track your arms and your legs and everything. Emotion detection, am I smiling, am I looking sad? You can build a lie detector around that. So all kinds of cool computer vision algorithms that we can use to basically hook a camera up to a computer, and the computer is now aware of its environment. The computer knows it's in a room, it can look out of the window, it can see its environment, it can recognize people and animals and cars, And you can build robots with that, or self-driving cars, or anything you like. So there are many cool computer vision algorithms. So I focus on that in a separate course. And the last course is about cloud AI. So that's all about scalable AI. When we're working with neural networks that are so incredibly massive that there's no way you can host them on your own computer. And you basically have to host them in Azure. So we're talking about neural networks with billions and billions of nodes and interconnections, which take months to train. So there's no way you can run that locally. If you tap into the cloud, you can do amazing stuff. For example, speech recognition, continuous speech recognition. It's now at a point that the accuracy is so high, it's higher than 99.99%, that you can basically use it to build applications. So like an Alexa speaker, you can easily build an Alexa speaker with Microsoft code if you offload the speech recognition to the cloud, because Microsoft has a massive speech recognition neural network hosted in Azure that you can just tap into through an API. I've used it for one of the assignments in that cloud AI course, and it's pretty amazing. It's like continuous speech recognition. I speak with a Dutch accent, and the computer understands me flawlessly, like perfect recognition. You can also try and do it locally. The .NET runtime contains a smaller neural network to do speech recognition locally, and the difference in quality is just enormous. Locally, it just doesn't work. The net is too small, so the accuracy is just not high enough to be useful. So you can do amazing stuff when you tap into the power of the cloud. So there's 4 courses, and I've bundled them under the name The Machine Learning Advantage. The advantage for you as a software developer if you focus on machine learning. So there's a URL at the bottom. Check it out, take a look. It's a nice landing page with some background information on the power of machine learning and how easy it is now to do it in C#. Just check it out and maybe join one of the courses if you're interested. Okay, so now I'll give you a tech demo. So I'll show you how to build an application that hosts and runs a neural network in C#. So I've got a little data set. It's a famous data set called the Boston housing data set. And it's basically a list of properties in the Boston area with all kinds of information about the properties. So like how old they are, when they've last been refurbished, how many meters from the road, you know, how long the driveway is, the area code, you know, where the house is located, the elevation, lots and lots of info, and the value of the house. So our goal here is to build a neural network where we can just plug this information in, and the neural network will accurately predict what the house is worth. And we can train a neural network on a data set of existing houses. And the neural net will learn to recognize patterns in the data. So it will build up an understanding of what exactly contributes to the value of a house. And then you can use the fully trained neural network to make arbitrary predictions on any house you like, just by plugging in that input data, and the neural network will predict a house value. So this is a very short application. It uses CNTK to host and run a neural network in C#. So let's take a look. I'm going to have to quickly switch over my screen sharing. Here we go. And then switch to Visual Studio right here and zoom the code a bit like that. So here's my code. So I'm in Visual Studio 2019. It's a fairly simple application. You can see here 119 lines of code, 119. And what this app does is it trains a neural network on the housing data set, and then yeah, that's it. It trains a neural network on the housing data set so that the neural network becomes aware of the patterns in the data and is able to predict the value of any house. So if you look at the code is really simple, of course. So I'm using CNTK, and this is all you need to do to pull in the CNTK library to use it. It's a single package called CNTK. And once you've got that NuGet package in your project, you just put a using CNTK at the top of your code and you're done. Now, CNTK is a low-level tensor library, just like TensorFlow. So you're basically dealing with neural networks at a very low level. So I've created a little wrapper library called Pensar, which is my own invention. It's on GitHub, so you can look it up. It's a small wrapper around CNTK that allows you to design neural networks layer by layer. The Python guys have their own library called Keras, which can do this. If you're a Python developer and you use Keras, then you can design neural networks layer by layer, just by creating a sandwich, basically. You just stack your neural network layers on top of each other and very quickly build a full neural network that way. So I really like Keras, but it's Python. So I built my own Keras in C#. So that thing it's called Pensar. It's a tiny library. It's basically just to support my courses. But it allows you to design and run neural networks with only a few lines of code. So here's how that works. The only thing you need to do is to use a training engine. So a training engine is a specialized class that can build up a neural network and then train it automatically. And I just need to configure the training engine for my specific use case and then run it, and it will train a full neural network. So there's only three things I need to pass to the training engine. The input data, the inputs that go into my neural network. So in this case, I have 13 different information fields that describe a house. So these are 13 different fields. So I need to tell the neural network that I want 13 inputs. Each input is a float. It's a floating point number. So all these data columns have been converted to numbers. So like, for example, the age of a house, you know, the number, the distance between the front porch of the house and the road, how many years ago the house was last renovated, and so on and so on. So these are all numbers. So all these 13 numbers go into the neural network. And then I need to define the outputs. So how many outputs would I like to have? So in this case, I'm predicting the value of the house, the price of the house. It's a single number. So I tell the engine that I want one float as an output, which will be the price. And then I design my network. So for this neural network, I'm going to create a very simple, fully connected feed-forward network. Fully connected feed-forward network. We also sometimes call these a dense neural network. A neural network built out of dense layers. And I'm going to create 3 neural network layers. So I'll start with my 13 inputs, and these 13 inputs will be mapped to 64 neural network nodes. So these are 64 nodes that receive the input information. Then I will pass that information to another layer, again consisting of 64 nodes. And finally, I will combine that information into a single output node. So my neural network has, and then a single output node. So this is the code to create that network. So I'm using a Fluent API here, where you can just chain methods together. You can just repeat the dense method over and over and over, and it will build up the network layer by layer by stacking these dense layers on top of each other. So you start out with the input side of the neural network, and then you just stack the layers until you reach the output. So at the output side, I want a single number, so that's the dense one, and the other 2 layers have 64 nodes. So that's the 2 dense calls that you see in the code. Now this thing here, this ReLU, we call this the activation function. It's a little function that modifies the behavior of a neural network node, and the ReLU function helps with training the neural network. It stabilizes the neural network during training. We pretty much always use ReLU in neural networks because it works really well. And that's it. So that creates a neural network. So now in my main application, the first thing I need to do is load the data that I'm going to train the neural network on. So that's all of this code right here. So this code will load the data into memory, and it loads it basically into a float array. So I have all my input data. You can see I'm loading the input data and the prices separately. So I've got my 13 descriptive columns that describe a house as one file, and I've got the corresponding prices as a second file. And I've also split this into a training set and a test set. The idea here is that I'm going to train the neural network on the training data, and then once the network is fully trained, I'm going to test its predictions. I'm going to use the neural network to create predictions for every single house in the test set, and I'm going to compare those predictions to the actual prices of the house, the actual values. So the neural network is going to make predictions, and there will be a real house value and a predicted house value. And there's going to be a difference between those two. And the total difference, so the sum of all the mistakes that the neural network is making, we call that the loss or the error. So this is how far off the predictions are corresponding to the actual value that we want to hit. So when I'm training the neural network, you would expect that an untrained neural network has a huge loss. It creates predictions that are nowhere near the actual house values. Once I have a fully trained neural network, it will have a very small loss because its predictions will very closely match the actual house prices. When we train neural networks, we do that in a loop. We are continuously training and training and training the neural network over and over and over again. And during this training process, the loss will drop. So it will start out high, and then it will get lower and lower and lower and lower, and hopefully we will hit zero. A loss of zero means that every single prediction the neural network is making is spot on. So that's basically how the training process works. So it's always a loop. So I'm loading my data and printing on the console and printing how much houses are loaded. And then I'm setting up the engine. So here, this is the constructor for the training engine. I need to provide a couple of values. I need to provide the loss function. So this is a mathematical function that we will use to calculate how far off the predictions are. I'm using a function here called mean square error, or MSE, which is the standard function to calculate the loss when we are predicting numbers, when we're predicting a price or an age or any kind of number, a temperature. When the output of a neural network is a number, then we always use this MSE loss function. So I'm setting that up. It's also asking for an accuracy function. So I say, do the same as the loss. So do the MSE function there as well. I'm training my network for 50 iterations. We call these epochs. So one epoch is one single loop where the neural network is trained once. And then I'm going to repeat that 50 times. So I'm training the neural network 50 times over and over and over. And it will get better and better and better at predicting the house prices. I'm using a batch size of 16, which means that during training, I'm chopping up my data into little groups of 16 houses. That's an optimization to help train faster. And I'm using a learning rate of 0.001. A learning rate is a value used by the neural network training engine to improve the neural network during each epoch. So the learning rate basically tells the engine how fast to train the neural network during each epoch. Finding these numbers is a bit of a dark art. If I put the learning rate too high, I'll never get good predictions. If I put the value too low, then it will take forever until the neural network is fully trained. So it's a trade-off between getting good results and speed. So I've experimented a bit, and 0.001 is a good value for this data set. So I've configured my engine. Next step is to load the data into the engine. So that's what this set data call does. So I'm loading the data into the training engine. I'm basically loading it into the neural network. And then with this single line, engine.train, I train the neural network on the complete data set. Now, during training, it will output to the console. I'll show you that in a second. And then finally, I'm plotting the loss value in a graph. So I'm creating a graph which will show you all the epochs on the x-axis and the training loss on the y-axis. So we can see how far off the neural network predictions are in the first training loop. and then how that slowly improves during subsequent loops. So we expect a graph that kind of goes like that, you know, the loss starts at high and then it drops as we continuously train the neural network. So I'm using a library here called plplot, and you can use it to quickly create scientific plots. That's the whole code. So I'm just going to run it. So here we go. It's loaded 404 training houses and 102 test houses. And there are the epochs. So what it's doing is the app is continuously training the neural network. So here you can see most of the epochs. So here are all 50 epochs. So you can see the neural network has been trained 50 times. And you can see that the initial training accuracy, so this is actually the loss value. The initial loss value is 565. So this is just the sum of the mistakes of all predictions. The sum of the mistakes in all predictions. So that's 565. So it's actually measured in, you have to multiply it by $1,000. So the network is off by $500,000. That's a lot. Now, as we go down, you can see that the loss gets smaller and smaller. So we start at 565, but then after 10 epochs, we're already down to 29. And then if we go to 30 epochs, we are at 14, you know, and it goes lower and lower, and we end at 11.2. So we brought the total prediction error down from 565 all the way down to 11, just by training the neural network 50 times over and over and over. So now this neural network has learned the patterns in the data, and it is now able to make predictions. It can predict house prices in Boston, and it's off roughly by $10,000. So it would quote a price for your house, and it would be off by around $10,000. So that's not bad, actually. So this is a really good result for a neural network. And you can see it's a tiny neural network. I just had these two 64-node layers with a single output, and I'm getting really good results already. So now looking at the final graph, let me quickly load that up. Here we go. So here's the graph that the code produced. So what you're looking at here is the improvement of the neural network over time. So all the way on the left, we have epoch 0, and you can see that the loss is 565. And then as we train the neural network, you can see the loss rapidly dropping and leveling off. And basically after, say, 10 or 12 epochs, we've hit a really good plateau. And we could basically stop training there. We've reached a point where the network isn't really improving much anymore. It's slowly converging down, but it's not really improving rapidly anymore. So we would pick a point somewhere, probably between epochs 20 and 30, where we would stop training and say, okay, this is good enough. You know, these predictions are accurate enough to work with. So there are two loss values plotted in this graph, the training loss and the validation loss. So the training loss is the errors in predictions for the 400 houses in the training set, and the validation loss is the errors in predictions in the 102 houses that were in the validation, in the testing set. Now, the reason that we measure both is because there's this really nasty thing called overfitting, which happens when you train a neural network, where the neural network basically stops performing well. It starts to create really bad predictions, and it's useless to use that neural network in practice. You recognize overfitting in a graph like this when you see those two lines diverge. So here you can see the lines, they stick together. The training and validation loss stays close together as we hit epochs 20, 30, 40, and 50. But when we would encounter overfitting, those two lines would start diverging. So we always measure two loss values, one for the training data and one for the testing data, just to be able to detect overfitting. So now I have a fully trained neural network, and I can use it to predict the price of any house in the Boston area. So you could use this in a retail website, for example, a real estate website. You could have a real estate website, And you would plug in any house in the Boston area, and the neural network would give a recommendation for a price for that particular house. And the recommendation would be off by only $10,000, which is pretty accurate, actually, for a house price prediction, especially if you're talking about houses between $500,000, $1 million. 10,000 is nothing. So it's a really small error. And looking at the code, let me quickly close the app. So, I mean, looking at the code, and this is just plotting code right here. So the code to train this neural network is super short. It's just a single line, the train method, right down here. Loading data in the neural network is just a single line of code, set data. Configuring the neural network training process is right here. It's just 5 property values to configure the training process. And then designing the neural network is just up here. It's 1, 2, 3, 4, 5 lines of code. So you can see with, it's very easy in CNTK to add neural networks to your C# applications and use them, train them on business data, and then use them to create valuable predictions that you can use in mobile apps, in websites, anything you like. So that, in a nutshell, is the machine learning advantage. So you are now in a position where you can add the AI and machine learning skill to your skill set. And you can branch out as a software developer into AI and machine learning. And you can add that to your set of skills. And AI is, right now, it's a blue ocean skill. So it's really in demand. AI software developers are really sought after. And the thing is, Python software developers are really sought after, sorry. So if you are a C# AI software developer, you are part of a very small exclusive team, and you'll always have work, basically, because how many business applications are written in C#? If you look at industry applications, if you look at large businesses, enterprises, 50% of all the code is C#, and the other 50% is Java. So Java and C# are the main development platforms used in enterprise. Now imagine you have this skill set to add AI, to add machine learning to those C# codes, to those implementations. No need to bring in Python, no need to muck around with virtual machines, with Python code running inside the VM and hooking it up to the existing C# enterprise software. No, you can directly add neural networks to an existing C# application. Now that's pretty awesome. And believe it or not, there are many companies who want exactly that. When I give these presentations, I often get very positive feedback from companies that say, we really want to experiment with AI, but we don't like adding Python code to our existing C# infrastructure because we don't feel that's a very robust solution. And that's absolutely correct. So by having this skill, by being able to build AI applications in C#, you can now help those companies. You can say, no, you don't need Python. You can directly add neural networks to your existing software, and your architecture will remain robust. It will remain stable. So that's a really powerful argument to make to companies. So that's the end of my presentation. So I hope I've convinced you that machine learning is a really unique skill that you can cultivate right now. And if you're in software development, this is the perfect time to get into machine learning and yeah, safeguard your career basically for the next 10 years. So if you have any questions, I'll go back to the presentation because I actually have a slide. There we go. So if you have any questions, please let me know now in the chat. If you have any questions about this, about the machine learning specialization, about C# and machine learning, about AI libraries for C#, anything you want to know about the code demo, just let me know and I'll address it right now. So if you want to ask me a question, use the chat function in Zoom. So there's a menu at the top and then just open the chat window and then just type anything. I've got the chat window open right here. So if you post a question, I will see it live. So I'll wait for your questions. And if not, I'll wrap this up. So I'll give you guys 10 seconds, 15 seconds to type something. see if anything's coming in. And otherwise, I will wrap this up, and I hope you enjoyed the presentation. I hope you realize now how easy it is to add neural networks to your C# code. I mean, neural networks is awesome, right? There are neural networks for detecting faces, for detecting objects. You can build a self-driving car. You could automate business processes. You could hook a camera up to a computer and film an industrial process. The computer would actually understand what it's seeing, so it can monitor an assembly line or a production line, and it could alert a supervisor if anything dangerous is happening. So computers can now see and understand what they're seeing. I mean, this is huge. It means we can build all kinds of cool applications now. So really cool stuff. All right, so no questions. So awesome. I hope you enjoyed this presentation. I'm recording this, and I will put the recording online, and I will email all of you a link to the recording. So if you joined late, no worries. Tomorrow, in 24 hours, you will receive an email. It's fully automatic, and it will have a link to a page where this complete video is hosted. So you can watch the beginning at your leisure and check out the whole thing. Check out the Machine Learning Advantage website. And if you have any questions about this stuff and you want to reach out to me, just reach out to me. I'm easy to find on LinkedIn and on social media. Just reach out to me, ask me a question, and I'm happy to help. All right, so thanks a lot, and hopefully I'll see you soon in one of my courses. Bye.